Hello, everyone. Welcome to TDWI's webinar program. Thank you for joining us today. My name is Linda Briggs. I'm a contributing editor here at TDWI, and I'll be your moderator today. Our program is Using the Cloud as a Platform for Data Warehousing, sponsored by Snowflake Computing. And for our speakers today, first up will be Colin White with BI Research. And after Colin's presentation, we'll hear from John Bach with Snowflake Computing. Before I turn the stage over to Colin to get us started, just a few items for the audience. Our webinar will be an hour long. At the end of the formal presentations, the speakers are going to host a question and answer period. So if you have a question for a speaker at any time during the presentations, please type it in there on your screen and send it over. We welcome your questions. We want to hear from you. If you run into any problems, any technical issues during the webinar, there is a help area below your slide window. You can click on that for some technical assistance. If you'd like to discuss this webinar on Twitter with some of your fellow attendees, you can include the hashtag TDWI in your tweets. Also, if you'd like to download a copy of today's presentation immediately, there is a click here for a PDF line there on the left middle of your screen. In addition, we are recording today's event, and we'll be sending each of you a link to an archived version. You'll be getting an email to that later today, so you can view the presentation again. Or please feel free to share that link with colleagues if you'd like to do that. Okay, once again, our program today is Using the Cloud as a Platform for Data Warehousing. Our first speaker is Colin White, who is president and founder of BI Research. As an analyst, educator, and writer, Colin is well known for his in-depth knowledge of data management, information integration, and business intelligence technologies for building the smart and agile business. With many years of IT experience, he has consulted for dozens of companies throughout the world and is a frequent speaker at leading IT events. Colin has written numerous articles and papers on business intelligence and data management as well, and writes for leading industry journals. So Colin, welcome. Let me turn the mic over to you.
Thanks, Linda. Hello, everybody. It's my pleasure to talk to you today. I'd like to thank TDWI and Snowflake Computing for inviting me to talk to you today. Hot subject, data warehousing in the cloud. The slide you see in front of you at the moment provides an overview of the webinar. I'm going to give my views on data warehousing in the cloud as an industry analyst, and then John will give Snowflake Computing's view and how it relates to my comments. The webinar overview shown on this slide is really extracted from the text you saw when you signed up for this webinar. I want to really highlight two aspects of this webinar and the webinar overview. The point we're trying to make, and I think you'll come out of this webinar, is that the cloud is an ideal environment for data warehousing. And this is specifically true given the changing data volumes and the unpredictable workloads involved in data warehousing today. Data warehousing is going through some significant changes. We're introducing new technologies, new platforms. We're trying to gather new kinds of data for analysis. So I think our volumes are increasing. And certainly our workloads have always been unpredictable, but they're becoming less predictable as we move towards these new technologies. So I think the elasticity of the cloud, the fact that the cloud environment can adjust to your workloads, and the fact you only pay for the resources you use, in the words of the pay-as-you-go model of the cloud, are very attractive to data warehousing users today. I think the other thing I want to emphasize in the overview is that one size does not fit all. I think the cloud is sometimes viewed as a way of bypassing IT bottlenecks, and of course, in the data warehousing space, IT can become a bottleneck because we can't analyze the data till we actually put it in the data warehouse. And some business users get frustrated with this process, and they use the cloud to bypass IT. I think we need to take a step back for that. We need a cloud strategy, and that's part of today's presentation. You know, the challenge is finding the right projects to put into the cloud. One size doesn't fit all, as I mentioned. And then secondly, what is the correct platform for deploying data warehousing in the cloud? A lot of vendors coming into the cloud space. Now it's getting crowded, it's getting confusing. And we hope today to try and sort out some of this confusion and try and at least give you some guidelines on how to really choose the right platform and how to choose the right projects for the data warehousing environment in the cloud. So if you look at the 4 bullets at the bottom here, the focus is going to be on use cases for data warehousing in the cloud and the requirements to satisfy those use cases. I'm going to give my views on how you choose a data warehousing solution. So those 3 bullets are going to be the focus of the webinar today. But of course, a lot of people that move into the cloud environment already have a data warehouse or certainly some kinds of reporting or business intelligence or analytical processing. And I'd like to spend a few minutes towards the end of the webinar talking about really how we integrate a cloud-based data warehousing environment with existing systems. A lot of what I'm going to be talking about today is based on a checklist report that I recently wrote. You should see that published towards the end of July. It was sponsored by Snowflake Computing, but it is vendor independent. It's my views on really how you address the topics that we're going to cover in this webinar, but in more detail. In other words, if you really want to gain a more detailed understanding of this area, more so than I can cover in 30 minutes, then I would look out for that report towards the end of July, the beginning of August. And if we look at this checklist, it breaks into the 3 areas I've discussed. The first three items on the checklist really look at understanding the technology that the cloud brings to data warehousing, identifying projects that are ideally suited to the cloud environment, and then really ways you can assess and match your use cases to different vendors' solutions. And then items 4 and 5 look at really how we go about choosing the right solution and look at the cost of that solution. One concern I sometimes have with IT in general, but also the cloud, is that people tend to just look at the cost of the hardware and software. I think in these kind of new environments, we have to look at the total cost of ownership. It's not only the cost of the hardware and software, but it is the cost of actually implementing these systems and managing these systems. And also to what extent the skills that you have today match to really the technology requirements of systems like the cloud and so on. And then lastly, items 6 and 7 really look at the existing data warehousing environment, looking at really how we integrate the cloud with the existing environment. And then secondly, to say, well, we tend to use new technologies like the cloud to implement new applications. But I think if I go and look at the people I work with, a lot of them are actually using the cloud to extend or enhance or modernize the existing data warehousing environment. So the last item there really looks at how we really use the cloud to improve what we do today. So I'm going to go through these fairly quickly, one at a time. And so let's start off with checklist item number 1. What are really the advantages of the cloud for data warehousing? Well, if we sort of consider the cloud, I think people realize, given how long the cloud has been around now, that the advantage are it is a pay-as-you-go pricing model that reduces the need to actually pay for hardware and software up front. In other words, you only pay for what you use. And secondly, you don't have to install the hardware and software. It's actually already installed in the cloud for you. So that reduces cost, but it also gives you faster time to value. And that's true also in the data warehousing environment. As I've already mentioned, in the data warehousing environment today, our storage requirements are going very rapidly, often unpredictably, and our workloads are becoming increasingly complicated in the data warehousing and analytical processing space, and it's becoming difficult to predict those workloads. And so I think the cloud offers advantages there because it's very elastic. It can adjust really the resources to suit our needs, and we only pay for the resources that we use. So these are really technology considerations. From a business viewpoint, though, these technology benefits really benefit the business as well, because we can actually implement applications faster, and therefore really data warehouse in the cloud also benefits the business as well, because we satisfy their needs much faster from an IT viewpoint. I think the other thing that is worth mentioning is that it aids data warehouse modernization. We are seeing a lot of new platforms, many different types of hardware, software coming out now that enable us to improve the data warehousing environment. Many of these are aimed at really acquiring new kinds of data. We tend to use the buzzword big data to describe that. So there's a lot of change going on in the warehousing environment which enable us really to exploit new technology of business benefit, to use really new kinds of data. And I think the other thing that's going on in the warehousing space is we are starting to move to an environment where we have one environment for production purposes. That may be our enterprise data warehouse on premises. But increasingly, we're building separate investigative computing platforms by which we can blend data together to look for how we can use this data for building new applications or enhancing existing ones. In other words, we're moving to an environment where we no longer have to integrate all the data in the enterprise data warehouse before we can start to actually look at its value. We can have a production EDW environment, but alongside that we can have an investigative environment that enables us to explore data, new kinds of analytics, decide which of these pieces we wanted to put into production. And really these two environments can both be applied, the cloud can be applied to both these environments, but it's somewhat attractive towards the investigative computing environment because obviously the data will be using there and the actual processing will be using there. It's extremely unpredictable, and so the cloud enables us really to be very successful in that environment. So item number 2 here is really about identifying projects that the cloud data warehouse can address. I think the cloud in general has been very attractive to small and medium-sized companies or very much business units that are independent of IT because they can actually get up and running faster with limited IT resources. In fact, many small companies don't have a lot of IT resources, and the cloud makes it very attractive to implement their data warehouse in the cloud. I think the other thing is that increasingly we're seeing a lot of business now really doing more and more business in the cloud environment. I mean, the amount of web storefronts growing and their volumes are growing now. And again, so a lot of e-business, even within traditional companies, that e-business is growing rapidly, but of course some companies actually run their complete business in the cloud. So I think it's important with the cloud in general, and particularly from a data warehousing viewpoint, is to start off with business areas and business projects that recognize the value of cloud computing. So the cloud computing has been around for a number of years, and so if you look at business units that really are committed to the cloud, that makes it easier to start using the cloud from a data warehouse perspective. And then we really need to look at your data warehousing needs that are not being addressed by IT, either for budget reasons, backlog reasons, or just lack of resources, or in fact, it may be that on-premises systems simply can't produce the performance you need to implement a specific project. So these are all areas that are attractive for data warehousing in the cloud. But in essence, if we look at these areas, they kind of break into 3 areas. One is companies that really do a significant amount of their business in the cloud. That obviously is a very good use case for data warehousing in the cloud. Standalone analysis of new kinds of data like web data, social media data, sensor data, and so on. We may actually want to do some analysis independent of the traditional environment to look at what kinds of data we can use and what kind of analytics we can produce to actually supplement our traditional environments. And then lastly, data warehouse augmentation or really modernization. We are starting to add additional components now to the enterprise data warehouse in the area of data refineries for actually pre-processing new kinds of data. I've mentioned this concept of investigative computing that sits alongside the production data warehouse. These are all ways we are improving the existing data warehousing environment, and again, the cloud lends itself to that type of environment. I think the other thing that's important to mention is that if we look at the complete life cycle, we may prototype a new application to show end users. We may try out new kinds of analytics and new kinds of data. For those prototypes that the end user would like to see implemented, that we then move into a development cycle, and then finally into a production environment. Each of these steps could be done in the cloud. In other words, we may actually prototype applications in the cloud, even if they're developed and deployed in-house, or we may actually develop in the cloud and deploy in-house, or we may actually do the whole thing and put really all our whole systems into production in the cloud environment. So it's not a one-size-fits-all, as I've mentioned to you at the beginning. So let's quickly look at each of these three areas in more detail. The e-business area I've covered quite a lot. As I said before, many businesses are really running their whole business in the cloud, but even in traditional companies, there is increasing interest in e-business from web storefronts and so on, and that data already exists in the cloud. Therefore, from an analytical viewpoint, it may actually be even advantageous to actually do your analytics in the cloud. But another example would be Salesforce.com. You know, many companies are doing CRM now in the cloud, and that data sits in the cloud, and therefore the obvious way to do data warehousing is to analyze that data in the cloud. But, you know, to give some other examples here, I've worked with web marketing companies where they actually want to spin up temporary data warehouses for a period of a month or two to do analysis for a new customer, or to actually analyze data on a monthly basis for actually deciding which advertising space people will use on websites. Online gaming companies, these companies are all moving into the analytics space to identify really what kind of services and products the gamers are interested in. So there are a lot of companies now using e-business more and more, and that data sits in the cloud, and therefore that's an ideal place to actually do cloud data warehousing for analyzing that space. Standalone analytic applications, I mentioned this before, increasingly want to use social media data, web data, even sensor data, for example, coming in from telecommunication switches and so on. We may actually want to investigate that data to decide which of this data we could use for business purposes. A lot of this data is technical in nature. We simply want to extract the business value out of that data. We may then want to analyze that, build prototypes, and in some cases even deploy in production in the web environment, in the cloud environment, or we may move that into an on-premises EDW for further processing. So this is again another attractive area for doing data warehousing in the cloud. One area that I'm spending a lot of time on at the moment is really looking at data warehouse modernization. Our traditional or classic data warehousing systems are becoming a bottleneck to implementing new technology, to implementing new kinds of data. And so companies are now looking at really thinking of the EDW as a production environment and look for ways of really using new technologies and specifically new kinds of data using a separate platform. I call this an investigative computing platform. The investigative computing platform can suck in new kinds of data, blend it with existing operational data, blend it with production data warehousing data to actually look at what value that data brings to the organization. And then you can actually use that data to put it into production in an EDW environment, or we actually may deploy that application, as I said, in the cloud itself. So the investigative computing area is very good for the cloud environment. In many cases, because of the data volumes involved, we actually put what's called a data refinery or data lake in front of the investigative computing platform to actually filter and transform the data before we move it to downstream systems. Again, if a lot of that data is coming from the cloud, a data lake or data refinery environment very much for processing cloud-based data, e-business data, social media data, and so on, can be used for pre-filtering and transforming data before we load it into an investigative computing platform. So these are two key components of really a data warehouse modernization project, and both of them can be deployed in the cloud. So they're the three areas that really are very attractive from a cloud data warehousing viewpoint. Assuming we've really selected one of those use cases for a cloud data warehousing project, the next question then comes up really is, well, what technologies and what vendors are we going to actually use for implementing the cloud environment? As I mentioned, increasing number of cloud providers these days. I personally think that you should start to look for vendors who really understand the unique requirements of data warehousing. So, for example, I see a number of people using Amazon Web Services, but that's a company that provides really a generalized set of services for cloud-based computing. What some vendors do is actually offer their own services or their own products on top of Amazon Web Services or their own platforms, but they focus on data warehousing, and I think Snowflake is an example here. They actually provide services, they provide a platform specifically for data warehousing, and they're trying to help really customers get up and moving as fast as possible in the data warehousing environment in the cloud. And I think you have to look at the complete supply chain here. It's not only providing a platform for actually deploying a data warehouse, but it's also about getting data into that data warehouse and then having loaded that data into the warehouse to actually to generate analytics from it. But also, as that data warehouse moves into a production environment, we're looking for services that enable us to actually administer that environment much easier. So we're seeing then really vendors coming out like Snowflake who address specifically the data warehousing space, and they provide additional services. A couple of examples I've seen from various vendors are services that make it easy to capture data from existing systems or e-business systems, excuse me, and actually make it very easy to bring in to a data warehouse on the cloud. They provide tools to make it easy to manage the cloud environment from a data warehousing viewpoint down to performance tuning, backup recovery, and so on. So I think you do need to look at vendors who look at data warehousing specifically and address the complete supply chain, but also offer a set of managed services over and above just simply a set of hardware and software. You have to be a little careful, though, about really what we mean by this term managed services. Many cloud-based vendors offer these services. Some of them are consulting, which tends to be attractive towards companies that have really not a lot of IT resources. Some of those you have to pay for. Some of those are free, or a certain amount of it comes free with the service. But these managed services also come in the form of additional tools, either for loading and backing up and recovering data, for integrating data. They may be tools to make it very easy to operate and manage and administer a data warehouse in the cloud. And so, again, it comes back to what I said. You need to, I think, focus on vendors that really understanding the data warehouse space and offer services either from a consulting viewpoint, particularly if you don't have a lot of IT resources, or where you do have a lot of IT resources or IT skills, they give you tools to make data warehousing in the cloud much easier to implement, manage, and really use on an ongoing basis, because you reduce the actual resources you require and you actually lower your cost. So I give an example here on the right-hand side of this green box. These are the kind of services you see from typically infrastructure vendors, but if you notice, it doesn't really say anything about data warehousing. So I think it's very important to understand what a vendor's offering in terms of these services. Are they free? Are they fee? Are they consulting? Are they administration tools? Are they data loading tools? And really, are they geared towards data warehousing specifically, or are they simply tools that are there to manage the hardware and software infrastructure? So what we've now done then so far is really look at the use cases for data warehousing in the cloud. We've looked at the kind of technologies and that exist, the range of vendors that exist. Now what we have to do is really identify the best fit. Use cases vary, projects vary. You've got to really understand the projects and choose the vendor and the service in the cloud that best suits your needs. And so this comes down to things like matching the hardware and software requirements, managing data management requirements, managing tool requirements, and so on. From a hardware and software viewpoint, really that's a question of matching the hardware and storage to your data volumes and analytical workloads. And as I've mentioned already, that's the advantage of the cloud environment, is this elasticity. It can adjust to your capacity needs, and then you only pay for the services as you use them. So that's the big benefit, and that's true, I think, of many, many cloud environments. From a system software viewpoint, that's going to very much depend on the data warehousing and analytical tools you're going to use, and obviously you need to choose a solution that can effectively support those data warehousing and analytical tools. And sitting under those tools, of course, are the data management systems that manage the data warehousing data. Up until today, we've tended to use relational database products for doing that, but we are seeing increasing use of non-relational systems like products based on Hadoop, open source solutions, and so on. And there's a big bandwagon there, not only in the cloud, but also on premises. I personally think these kind of new options are used more for extending the data warehouse rather than deploying really existing data warehousing systems. The other thing you have to watch very carefully here are the complexity of these systems, the skills required, their reliability, and their total cost of ownership. So your mileage may vary. So I would really consider that the heart of a data warehousing system is still relational technology, regardless if that technology is being deployed in the cloud or on premises. But some of these non-relational and open source options can suit certain niche areas of your projects, and they are worth considering, and it's a piece of the puzzle that you need to take into account. From an analytical tool viewpoint or analytical application viewpoint, one interesting thing that may happen here, and this applies also to new on-premises technologies, we are seeing new data warehousing tools coming out, particularly in the analytical space, and you may end up with use different tools in the cloud than you do on premises. And that's something you need to consider, because really the business users should not be aware of where the data is stored. They should have a single interface to the data, ideally with a common set of tools. That's the key thing here. So we need to consider then that if you are going to access data across multiple cloud systems, or if you are going to access data that's both in a traditional or classic enterprise data warehouse and the cloud, you need to look at really to what extent you can use the cloud vendor solution to make the location of the data transparent and the tools you're using transparent to the business user. That's very important. You don't want to, ideally, what you don't want to do is have to retrain your business users. Data integration is always a very resource-intensive task in any data warehousing project. That's becoming increasingly complex as we start to integrate new kinds of data, particularly multi-structured data from the web, sensors, and so on. So even if this data already exists in the cloud, the data integration task does become more complicated. And again, this is why really working with vendors that understand data warehousing in the cloud is important, because I think they can provide services, either consulting services or potentially tools that enable you to actually integrate that data into a cloud data warehouse. That becomes really very important there. There are other areas that are not necessarily data warehousing oriented, but certainly other areas that you need to consider that may be different from the cloud vendor's solution to your in-house IT environment. Are the technologies the cloud vendor's using different from those used in-house? Do you have the skills required to actually support the data warehousing technologies in the cloud? What are the tools for and technologies for accessing, importing, and exporting data? I think if you want disaster recovery, if you want to make sure you have a copy of your data on premises, just in case of a disaster situation, what tools are provided there? What tools does the vendor provide for workload management? How secure is the cloud environment? Help desk capabilities. Ideally, you want your IT help desk to work in conjunction with a help desk provided by the cloud services provider. Again, because what you don't want is every single user having to call up the cloud provider to actually report problems. You need a mechanism there by which your in-house help facilities work in conjunction with the cloud help desk facilities. So what else? Cost and complexity is really an issue we need to consider here. I've already covered most of this. We need to look at, from a cost viewpoint, at the total cost of ownership, the complete cost of both not only deploying system but administering it, not just hardware and software. I keep coming back to this point of data integration. Some people find the cost of bringing data into the cloud expensive. I've seen vendors, for example, businesses, for example, keep their low-usage data into the cloud because it's expensive to bring in and out of the cloud. Again, that's going to vary by vendor, and you need to discuss that with your cloud services vendor. Managed services, I think we've addressed fairly well here. As I've said before, there's a difference between managed services, either from a consulting viewpoint or from a tools viewpoint, that are simply based around hardware and software, compared with services really to support the data warehousing environment. And I think it is these services that are a key distinguishing feature between different cloud vendors. Integration, again, I think I've covered this very well. I think we've covered the data area fairly well from an end-user viewpoint, from an analytical viewpoint. Ideally, we want an integrated tool set. So we're not only looking for deploying data in the cloud, we want to analyze the data in the cloud. That's where our value comes from. It's insights into our business that's valued from a data warehousing viewpoint. And so that really, those capabilities may come from the vendor themselves, or they may have partnerships with third-party vendors to provide those capabilities. But you do want a complete end-to-end solution, both from a data integration viewpoint, but also from an analytical viewpoint as well. And that's really shown on this chart here, that users may need to access both cloud and in-house data. They may access multiple cloud environments. There's nothing really new here. I mean, we actually are moving even on premises to accessing and analyzing data stored in multiple places. Very few companies have one enterprise data warehouse. And so we have two options. We can use virtualization kind of approaches to provide a single face to this dispersed data, or we simply move data to where we want to process it. So we may move traditional data into the cloud, or we may move cloud data into the on-premises to analyze it. So you either analyze it where it is, or you actually, using virtualization, for example, or you move it to where it's going to be processed. We want to keep data movement down to an absolute minimum because it can be expensive to move data around the network. So I've already covered then really the main aspects of data warehousing in the cloud. And as I said before, this can be typically used for building new applications, but it can also be used for extending existing applications as well. We can use it for overcoming performance and cost issues in-house. There may be applications that are not performing well. We can move them to the cloud to give them more capacity. Some of those applications may be very costly to run in the cloud. on premises, and it would be cheaper to run them in the cloud. So again, I think we can look at our existing environment to look for opportunities. We can also use it to enhance the existing data warehouses, this data warehouse modernization. I've talked about really using investigative computing platforms sitting alongside the production data warehouse. So even if you decide to leave your production data warehouse in-house, a lot of investigative computing could be done in the cloud. If we've got a lot of cloud data, web data, social media data we want to analyze, we can actually put data refineries in the cloud for pre-filtering that data. In other words, rather than bringing in all the data on premises, we can pre-filter it and transform it before bringing it on premises or to an investigative computing in the cloud. So again then, we can use the cloud for existing applications, or we can use it for building new applications. The title of this presentation is Data Warehousing in the Cloud, and I've tended to focus a lot on data. My view is that data forms the basis of what we want to do. The cloud is an extremely valuable tool in deploying data warehousing in the cloud. But the key thing is, inside is why. We simply don't want to use the cloud to dump data. We actually also want to implement in the cloud our analytical processing as well, so we can use it for business value. So I've finished. I've run out of time. Please enter your questions if you have any for me, and I'll hand back to Linda to introduce John.
All right. Thanks very much, Colin. Yes, as Colin said, we welcome your questions. Please do send those over. As I said earlier, at the end of today's event, after our next speaker, we'll be addressing audience questions. So we do want to hear from you. I see some good audience questions coming in already. On that note, please welcome our next speaker, John Bach with Snowflake Computing. John is the VP of Products and Marketing at Snowflake. He spent over 15 years creating and applying disruptive enterprise technology at both startups and established enterprises. Most recently, he's held product and marketing roles for companies focused on data analytics, including Astrodata, Teradata, and Cloud9 Analytics. So John, welcome to TDWI.
Thank you, Linda, and thanks, Colin, for that background and that overview. It's a great framework to use to think about what you need to be analyzing to determine the right cloud data warehousing solution and the right use cases for that. What I wanted to do was talk a little bit about how Snowflake has applied a lot of the thinking that Colin talked about and really taken a hard look at what does it really take to build a cloud data warehousing solution that can be used by customers to solve the problems that they had in traditional environments as well as new problems that they have, particularly as those apply to the cloud. Snowflake was built by a team of experts in data and data processing. So we have senior architects from the traditional enterprise data warehousing vendors. We have practitioners from companies that deal with large volumes of data, as well as companies who really understand cloud and cloud software and cloud infrastructure. What we started with was the idea that we really wanted to focus on what would it take to build a data warehouse that is ideal for the cloud environment. Certainly, as Colin said, there are some things that are going to remain in data warehouses that are on-premise, but we saw huge opportunities. We saw huge amounts of data and processing being done in the cloud. But we realized that there hadn't really been a data warehouse that had been built specifically for the cloud. And so we started with that as really a key focus of what we wanted to do. To do that, we realized that you really needed to start from the architecture. So certainly there are a lot of different options out there today that have been designed for on-premise environments that you can run in the cloud. But we did see that there's a lot of limitations in taking an existing on-premise architecture and taking that and trying to apply it to cloud without making significant changes. And so we saw that there was a really huge value proposition in focusing on redesigning a data warehouse for the cloud environment. As Colin also mentioned, we did see that SQL and a database focused on SQL are still extremely relevant, even in the era where we hear lots of discussion about various big data solutions and platforms. And so being able to build an engine that was at its heart still a SQL engine, but then to go and extend that to areas that traditionally hadn't been the domain of SQL engines was a key part of what we wanted to do. We also wanted to make sure that we could deliver that as a service. Colin talked about just the importance of taking some of of a vendor taking the tasks that used to often be left to the customer and making those available through services. And so we really wanted to deliver a data warehouse that really is a software as a service offering and not just an existing software package that had been added to the cloud. We also wanted to make sure that we could take that and support more than you could traditionally do in a relational data warehouse. So we wanted to support a broader variety of both data and analytics in the solution that we built. And so that was another core principle. Certainly a lot of the different types of data that Colin spoke about that are cloud native are not traditional relational data. And increasingly, even inside the enterprise, there's a lot of data that's being generated that is not traditional relational data as well. And we realized that it was just critical to make sure that the data warehouse could actually handle and process that data in an optimized way. So if I start with the architecture aspect of this, when we looked at the traditional architectures that were out there, we found that a number of the design assumptions that those architectures had simply weren't true in the cloud. Many of the architectures that are out there today for data warehousing were actually designed up to maybe 20 years ago. And 20 years ago, certainly, cloud was not a big focus for people. So we started looking at those assumptions, and we realized that that really necessitated a different architecture because of the different assumptions that are true in the cloud. And one of those is the assumption that scalable enterprise class storage is actually quite expensive if you do that externally. And so, this is the case that led people to develop the shared nothing architectures that have come to dominate data warehousing today. Because it was actually faster and cheaper to have solutions that used the storage capacity that was on the compute nodes, rather than the expensive storage capacity that was available external to a processing environment. Another key assumption that was true on-premise but not true in the cloud is that resources are limited and hard to change. Once you've deployed an on-premise data warehousing solution, it's often very time-consuming, very painful, and sometimes even requires a forklift upgrade to change the capacity of that solution. In addition, once that data warehouse is running, you tend to spend a lot of time having to figure out how to allocate resources among all the different jobs competing for those resources. And so there's a fundamental limitation there that is very different in the cloud. In the cloud, resources are relatively inexpensive to get and can be acquired on demand. And so that notion of elasticity that is really fundamental to the cloud is something that a traditional data warehouse really wasn't designed around. So even when you can add nodes to a data warehouse, there's still often a significant amount of overhead as the data warehouse needs to reshuffle data, reoptimize, rebuild metadata in order to get back to a state that it can optimally process queries. And then one additional assumption that we saw kind of built into just the fabric of data warehousing in the on-premise environment was that different data and different uses of data, different workloads, are best handled by siloing those into different systems. So in the cases of different data, we've seen that it's very common to have different databases or data platforms for different types of data. So the most common example we've seen is that people certainly will put their structured data into a SQL relational database for querying, but then we'll use a different platform to take semi-structured data or flexible schema data and to process that data and sometimes query it in those systems or sometimes then export aggregated converted results to a relational database. Another aspect of this is that in a traditional on-premise environment, one of the ways that you solve the challenge of scaling up workloads and concurrency is by deploying data marts. And so in many cases, data marts are deployed primarily for performance isolation reasons. And that's become a very standard architecture. The very common hub and spoke architecture that we've all seen many times is in part designed to alleviate and address some of those performance concerns that you have in a traditional environment. Now, in the cloud, there are certainly a lot of options that you wouldn't have had to get the concurrency, the workload scaling and such, that you wouldn't have had. And I'll talk a little bit about our approach to those at Snowflake in a second. So as mentioned, this really led to these assumptions really led to the current approach to data warehousing. That approach that, it was necessary to bring the data to the compute, to have a shared nothing architecture that processes data there. We saw that as being a limitation that didn't necessarily make sense in the cloud. In the cloud, the external storage is very cheap, it's very scalable, and it's enterprise class. And so as a result, it's actually the external storage in the cloud that is cheap and scalable, and the internal storage that's expensive and less scalable. In the cloud, if you want to use internal storage, you actually pay for the compute, and in the cloud, compute is the expensive resource. So the architecture where to support all the data that you need to bring that into the compute layer just doesn't fit the cloud model very well. It makes it a much more expensive approach, and so that's one of the reasons that we wanted to change that architecture. We also saw that the traditional architecture, the way that was designed was really to address that scenario that we talked about where the resources available are fixed at any given point in time. And so it became extremely important to plan in advance for the capacity you needed. I've certainly talked to people who had to plan 3 years in advance when making a data warehouse purchase for the peak load that they would need on their peak day of the year 3 years down the road, because it was such a big project to actually move and scale a data warehouse. And so that's just a design assumption that's really been built into current architectures. And then as we spoke about before, this whole hub and spoke notion that's for performance isolation is certainly a feature that we've seen in on-premise deployments as well that doesn't necessarily meet the capabilities you have in the cloud. So turning to how we address this at Snowflake, so as I mentioned, we started with a new architecture. We didn't start with an existing database package. We didn't start with an existing big data package. We actually designed a new engine because we saw that the architecture needed to change. And one aspect of that is that we wanted to centralize data in scalable, cheap cloud storage. So we run today in public clouds. Today, Amazon Web Services is the cloud that we support, and it certainly is where we've seen the most customer data and customer processing. And we leverage the cloud services that are provided in these public clouds to get access to cheap, scalable enterprise-class storage. Now, at the same time, we also wanted to be able to bring compute to that dynamically. So unlike a traditional architecture where the storage and the compute are in fixed ratios and you have to scale them both together, we saw that there's a huge benefit to being able to bring compute dynamically to process queries and operate on data based on the needs that you have at a given time. So unlike a traditional architecture where you size it, you run things, and it's a painful process to resize it, we actually have a fully dynamic system that allows you to have independent processing clusters that can all operate on a shared pool of data. So the hub and spoke architecture that was very common in traditional environments can now be achieved in the cloud in Snowflake without needing to have multiple copies of data and have to worry about multiple ways in which you have to distribute data to different data marts. In this case, I can have multiple independent processing clusters all accessing that same shared pool of data. And because those are independent processing clusters, they are isolated from each other in terms of performance. So there's no performance degradation as I scale up users and workloads. So this helps to address that challenge that's very common in a traditional environment. You have to scale everything together. So if you have a huge amount of data, if you were to have hundreds of terabytes of data, but on a given day you're only processing a small subset of that, a traditional architecture would force you to build a cluster for the maximum amount of data that you want to store. What we've done in our architecture by separating the storage and the compute capacity, allowing you to bring those together dynamically, is we allow you to get the perfect balance of storage and compute. So that, for example, if I have a huge amount of data, hundreds of terabytes of data, I can store that in low-cost cloud storage and have it immediately available for querying as soon as I spin up one of these compute clusters, which we happen to call virtual warehouses. So I have the full flexibility to spin up a compute cluster that's exactly sized for the workload I need to run. So if I have a workload that only needs to look at the last week of data, I can size that virtual compute cluster for that amount of data, and I don't have to size it for the entire data set that I might want to store. So I have the benefit here of being able to bring together lots of different data, keep that data in low-cost storage, but have it immediately available for optimized querying in a way that I certainly wouldn't be able to have in a traditional data warehouse environment. And then in addition, we wanted to make sure that we could provide this all in a single system. So unlike the scenario where you have multiple data marts and you have to assign users to different data marts and potentially, or maybe you have to shard if you have one core system and then you want to scale that, what we did at Snowflake was make this all part of one single system. So Snowflake is a single system that you as a customer can use, but within it, there are all these services that take care of providing the compute clusters, keeping track of metadata, implementing the security policies that you set. All that's taken care of by the cloud service that Snowflake provides. So that comes into play when you think about what you as a customer and user need to manage. The entire system is a data warehousing solution and not something that you need to stitch together for parts. We actually have customers who don't even have an account in a cloud services provider, but are able to use Snowflake because Snowflake takes care of all of the management of that for them. Another key aspect that we wanted to address in our design and our architecture was that case of how do you handle diverse data in an optimized way. So what we did was we took a look and we saw that a lot of those sources of data that Colin was talking about as being some of those web sources of data come in semi-structured form. And that could be something like JSON, something like Avro, sometimes even XML. And that data traditionally hasn't been a natural fit for a data warehouse. Traditionally, you've had to transform that data beforehand in some ETL process or in some other big data platform. And only after that do you have it available in a form that can support SQL querying, whether within another platform or within a specialized analytic database. Well, at Snowflake, we actually, from the start, designed our SQL relational engine to extend it to support semi-structured data as well. So you have the full benefit of being able to work with flexible schema data without having to transform it to relational beforehand, and without suffering from the performance overhead that you would have if it were stored in kind of an undifferentiated blob. So when the data is loaded, we actually load semi-structured data natively. We transform it into an optimized form that we store internally. And then when you come to query that data, we use the information that we've gathered about that data to provide optimized querying in the way that a database knows how to do. So we can effectively get all the full benefits of database optimization even on semi-structured data, and this is fully transparent to the user. There's no need for the user to worry about transforming the data. It still looks like semi-structured flexible schema data for the user. But they have the flexibility then to provide relational views on top of that, so that tools and such that understand relational data can still work with that data. And then the last aspect that's really key to how we designed this was the aspect of making sure that this is a software service. In a traditional environment, you as a customer are responsible for everything from infrastructure all the way up to your actual data and queries. If you just took a existing database software package and put it in the cloud, you would still be responsible for a huge share of that stack. At Snowflake, we actually made sure that we designed as part of our service a lot of the capabilities that are needed to make this something that you don't have to manage yourself. So whether it's data partitioning and distribution, that's something that's automatically managed by Snowflake, doesn't need to be managed by the customer. And we do that adaptively based on queries and data. Whether it's something like metadata management, that's automatically handled by Snowflake, transparent to the user. Also, concurrency. So, unlike other systems where you have to very carefully manage queues and workload management rules, in Snowflake, concurrency is managed by the system, so you don't have to worry about handling that. And availability and resiliency is built into the system. DR, recovery, data protection, all of that is just a feature of Snowflake that doesn't require user management. So the end result of all this, is a big difference from what people have in many cases been looking at, whether it's looking at new use cases or even looking at whether a cloud data warehouse makes sense for them instead of an on-premise data warehouse. A few examples here are that we've had customers who come in and found that it's actually dramatically faster in the cloud, and part of that is due to the elasticity of the cloud, but also due to the architecture that Snowflake has that takes advantage of that. We've also found that people are able to not have to staff up additional staff to handle other platforms, tuning, things like that. And so for them, that's a win in that money that would have otherwise had to go into maintaining the system and optimizing it can now be going into more sophisticated analytics. And we've also found that people have, in many cases, been using various NoSQL platforms for really doing SQL analytics on diverse data. And in that case, the Snowflake approach and the Snowflake architecture make it possible to do that faster and less expensively, in a cloud data warehousing environment than in those other options. So that's just a quick introduction to how Snowflake approached the question of how to optimize data warehousing in the cloud. I wanted to turn it back over to Linda because I know we have a number of questions waiting out there from the audience.
All right, that's great. Thank you, John. Yeah, let's go ahead and move into our Q&A and address some of these audience questions. Let's see. I want to start with one about security in the cloud because we've gotten several of these. Colin, let me hand this one to you and then let John tackle it as well. This one is, how do businesses work through data security challenges around the cloud?
Yeah, I mean, you mentioned there were several questions. That comes up all the time, although I think companies are becoming more aware that data is very secure in the cloud. In other words, in my experience, often data is more secure in the cloud than it is on premises. In fact, if you look at many of the issues that come up with security, even with e-businesses, often the problems that occur of stealing data and that actually are coming off on-premises systems, not cloud-based systems. So in my view, if you go around and look at cloud vendors, you'll find actually that they are more secure than on-premises. And that's important because if they get a data breach, then their business is gone. So they have strong focus on security. So I think it's becoming less of an issue, and I think organizations are becoming aware that it's less of an issue. Obviously, there are legal reasons about where you can actually store data, like physical location and so on, and they have to be layered on top of that. So I think from a security viewpoint, the cloud is just as secure, if not more secure, but obviously layered over that, there are corporate policies and government policies that you have to consider. John?
Yeah, so those are great points, Colin. And I think the fundamental way that I think about this, and that I've seen more and more people look at it, is that it's not really necessarily about where the data is that makes it secure. It's about how you protect the data. And so I think traditionally we'd all kind of worked under the assumption that the firewalls that we put in place meant that a data center that we controlled was more secure. That assumption has pretty much been destroyed by all of the recent things that we've seen many times in the news, and many of others that I'm sure we haven't actually seen that have happened. And so as Colin was saying, in the cloud, it's still important to secure data, and it's extremely important to really, really push your vendor to make sure that they're giving you all the tools you need to secure that data. But compared to trying to implement all aspects of security with your own limited staff versus leveraging the capabilities and the focus that an external vendor can provide on security, can often lead to a more secure solution overall.
That's great. Thank you both. Let's see. Let's go to John Bach, our Snowflake speaker, with a couple of specific questions. John, are there specific, well-known BI tools that can connect to Snowflake?
Yeah, so because we built this, as a core SQL engine, we actually are able to provide standard JDBC and ODBC connectors. And so that opens up connectivity to a broad array of standard tools out there. So fundamentally, any BI or ETL tool that can speak to a SQL database using one of those connectors can speak to Snowflake. And in addition, we've also worked on optimized connections for tools that do have means by which we can optimize that connectivity.
How about this one? Could Snowflake be used as a data lake, or is it more appropriate as a data warehouse?
Yeah, it's a great question. I think the first question, of course, is what kind of are the characteristics and requirements of a data lake? And the typical definition that I've seen are, can it handle diverse data in pretty raw form and support ongoing exploration and refinement, but without doing so, without having a high cost associated with that? And so if you walk down that list of requirements, Snowflake definitely fits most of those. So I wouldn't say that Snowflake is a place where you're going to dump unstructured data. So if you have video data, audio data, things like that. But basically anything that's semi-structured or structured data, you can dump it into Snowflake in raw form. The way that we store data makes it very inexpensive to store that data, even long term. And then when you want to do exploration or refinement, you can spin up the processing resources that you need just for the times that you need to do that. And you store the results in Snowflake as well. So in many of the aspects of what people are looking for in data lakes, I think Snowflake is a good fit.
All right. Let's see. Colin, you touched on this issue of moving data to and from the data warehouse in the cloud. A couple questions on that. Here's one. What are some best practices to make incremental refreshes of the data warehouse in the cloud efficient to lower data transfer costs?
Yeah, I mean, there's, as you said, there were a few questions around that, and perhaps I can make more of a general statement. I mean, in a way, it doesn't really matter if you're in the cloud or on premises. Getting data into a warehouse is always a challenge, particularly if it's high volume, particularly if it's coming across the network. And so when we design data warehouses, we sort of put procedures in place to determine really how often we're going to update the warehouse. Do we actually stream the data across? Do we do it in mini batches? And then we actually put the network bandwidth in place to allow us to do that. And really the cloud is no different there. I think the considerations are the same. The only real difference is you're coming across the public internet. But I think given the increased use in e-business by most organizations, they're actually looking really at improving their network performance capabilities when using internet processing. So I think the only real difference between a cloud environment and on-premises environment is really the network speed. And you need to take that into account. Are the internet connections going to be using as fast as they would be as on-premises? But other than that, the basic decision-making and the techniques and technology you put in place are identical. John, what do you think?
Yeah, so I think, as you said, like it's very important to think about how you want to move data. Certainly, if you were going to move, an entire data set over to the cloud on a daily basis, it would be, relatively inefficient. So what we've seen is that basically there is a one-time move of the initial data set, and certainly that can take some time. But once you've done that, especially given the flexibility of the cloud, you can often do kind of trickle or micro-batch sort of loading that you couldn't have done in a traditional environment. And so that, as you mentioned, Colin, certainly does simplify it. There are also third-party tools that can be used to leverage deduplication and other ways to make the transfer of data over the network to public clouds more efficient. And then another aspect of it certainly is that in a lot of cases we actually see that many of the sources of data, and particularly the high-volume sources of data that people have, often start outside their own data set already. And so, the scenario where you use the cloud to integrate that data as a landing zone actually can make a lot of sense and make it more efficient than trying to first pull that data from external sources, bring that into your data center, and then send it back out to the cloud. So it certainly depends on thinking carefully about how you want to architect that, but there are many options and scenarios that can make the cloud a perfectly good fit for making sure you can get access to data on a very responsive basis.
Here's another good Snowflake-specific question, John. How do you store structured and unstructured data in Snowflake?
Yeah, it's a great question. So from the user's point of view, we make it look like structured and unstructured data are both stored in their native form in Snowflake. But what we do under the covers is the structured data we store in columnar form, since that is obviously more efficient for both querying and for compression. These semi-structured data, we actually will introspect that data as we load it and look for repeated attributes. And we'll take those repeated attributes and we will break them out and store them independently in the same way that a columnar database would store a column. So you can think of it as basically bringing the efficiencies of columnarization into the semi-structured world, but we do that on an adaptive basis. So even if the first 1,000,000 records have a certain attribute and the next 1,000,000 don't, the system is fine because it'll break out and store separately those first 1,000,000 and have the metadata that's built on those. And then when the next 1,000,000 don't, that's fine as well. So basically, having those two, optimizations allows us to give you efficient processing, and then we give you access to that data through SQL extensions that we provide.
Let's see. Thank you, John. How about this one? Does Snowflake have its own infrastructure, or can others be used? For example, Amazon Web Services. You touched on that.
Yeah, so just to recap, so Snowflake does run on public clouds, and today Amazon is the public cloud that we run on. We certainly are always investigating and looking to see adoption of other public clouds, and can certainly architecturally support other public clouds in the future.
All right. Thank you very much. On that note, we're out of time here. In fact, we've run a little over. Great questions from the audience. Thank you both. Our speakers today, Colin White with BI Research and John Bach with Snowflake. Also, we want to thank Snowflake Computing for sponsoring today's webinar. I want to remind everyone that we did record it. If you want to revisit the webinar or share the link with colleagues, we'll be emailing that to you later today. And in summary, I want to invite all of you to visit tdwi.org for more in-depth information and education on related topics. That includes the Analytics Experience. It's a new TDWI event coming up next week in Boston. It's for business and technical leaders and features classes, peer-to-peer sessions, case studies, and professional networking. Again, that's coming up in Boston, July 26th through 31st. And on that note, thank you all for attending today's webinar. This concludes today's event.